Hello everybody, I will start my today's another live coding session. So in my today's video, I will solve this question. Longest substring without repeating characters. So I'm giving string S, finds the length of the longest substring without duplicate characters. Okay, so in this question, an input is a string S, and the output should be the length of the longest substring. And substring, length of the longest substring without duplicated characters. Yep. And for the definition of the substring is this: a contiguous non-empty sequence of characters within a string. Okay. So in this question, I'm given some string like this, and I will try to find the substring which doesn't have any duplicate characters. So for example, I start from A, I can take under this. So now this should be length 3. Yep. And if I start from B, I can take under B A, so it should be BCA. If I start from C, it should be CAB. If I start from A, it should be AB. If I start from B, it should be B. Yeah, so in this way, I can find the substring without duplicate characters, and I will return the longest length. Good. Okay, as the edge case, I think this is trivial, but if it is an empty string, I should just return 0. Yeah. And S consists of English letters, digits, symbols, and spaces. Good. Yep. But for space, yeah, it can be like this: a digit, 1, space, and symbols. Symbols and space. Yeah, like this. In this case, I should return 4. Nothing is duplicated. And space is counted as 1 character. Good. Okay, so I could see an example here. Good. And I think for the brute force approach, I almost explained this with an example. So I will start from every character and try to create the string, substring, until, I will try to find the end of the substring. And the end of the substring is 1 character before the starting character. Actually, no. Yeah. For example, in this case, if I start from A, I find B here, and then I find B here. So ABB is not valid. So I should keep track of all the characters I've seen in the set. Then in the next character, when traversing, I check new character is in the seen characters. And if yes, yeah, that's the end of the substring. Yeah. Anyway, in this way, I can find the longest substring without duplicated character for each start character in the linear time. So it should be O of n squared time complexity, assuming that there are n characters in the string. But I'm pretty sure I can speed up a little more. So, for example, in this case, I will think, what's the longest substring which ends with A? Yep. So, first thing, I will use the sliding window. Yep. So let's think, what's the longest substring which ends with A, which is A. Yeah, that's it. And for B, what's the longest substring which ends with this B? And I can start from this A. Yeah. And AB is the one. For B, I will think because B, I have the B in the end. I can start from every character aside from B. I mean, I cannot start from A or I cannot start from this B. I can start only from this character B. Good. Then I get A. And the interesting thing is that when I think of this end A, the start of the substring with a duplicated character is at earliest here, at earliest this B. Because if I take one character before, like this B, it invalid because they're duplicated characters. And the reason why is I shrinked this window for the case when the last character is B here. So I could shrink as much as little as possible so that I don't have any duplicate. Which means that if I expand one more character before, which is a duplicate. So what I can say is when I think of the end character A, the start is at earliest here, this B. Yeah. And when I think of this B, last B, again, I will think of the, longest string with the duplicate characters, which ends with the last B. And because of the previous result, I can start at latest from this B. Sorry, at earliest from this B. And when I check this, B is duplicated, so I have to shrink it. And it becomes AB, and I don't have to shrink it anymore. Okay, so this is the basic algorithm. So I would say for each end, shrink start, or I should say move start until there is no duplicated charts in the window. Yeah. Then update max ranks to be returned. I say global max ranks. Then I return the global max ranks. Yeah, this is the basic algorithm I can use. And every time I will count how many characters there are in the window. For example, here I have 1A, and here I have 1A and 1B. Yeah. And again, when I think of this ABB, what happened is that the previous result is like this, A1, B1. Yeah. And I will try to find the substring which ends with B, and I start from this A, as I said before, for the start index. Yeah. And how much do I have to shrink? It is until there's no duplicated characters in the window. So for example, I mean, once I shrink this one character, it becomes a 0 and B1. And I still have to shrink it because B has no two elements. There are two B's. So I shrink this again. And when I do this, yeah, it becomes like this. Sorry, this should be 2. Yeah. And now it's fine because for each character, A and B, for A, there is only, 0 character in the window. For B, there is only 1 character in the window. No character has 2 or more characters. So this is good. So I can say the shrinking is finished. Yep. So as I could see from here, I count the number of characters in the and store it in the counter. Yep. So this is how it works. One thing I will be more specific is that how much operation, does it take to shrink? So when I move the pointer, obviously it takes only the constant time for one move. But every time I move the character, start index and shrinking, I have to check if there are no duplicate anymore or there is a duplicate. Yeah. So for example, if I reduce this, I find A1, B2. Yeah. So obviously what I can do is not only the counter of each char, I also count, or I just say keep track of the non-duplicated characters. And every time, if I find a duplicate character, which means that if I move the end index, and when I increment it, like this, I increment this, and now here I could say 2 chars, 2 duplicated chars. And in this timing, I increment the num-dup chars. Yeah. But even if I find one more B and it becomes, for example, A1, B3, I don't, increment this. Or maybe it never becomes 3, I think, because every time after I move, moves the end index, the start index is moved and the window is shrinked until there's no duplicates. So yeah, I think number of duplicated characters for one specific letter should be up to 2. But anyway, every time the duplicated count becomes 2, or I should say, number of specific characters becomes 2, I increment the num-dup chars. And when I, for example, here, yeah. So in this case, decrementing the number of characters B caused 1 B char. So num duplicate should be decremented by 1. Yeah. So in this way, I can count the number of duplicated characters in the constant space, and each move takes only the constant time, because checking the window if it has duplicated multiple chars for the specific char, or each char for each char takes only the constant time. Good. So yeah, this is what I can use. Until move start until. This means that num duplicate chars is 2 or larger. In this case, I have to shrink. Yep. Okay, so for now, time complexity, this takes O of n. because end character and start character moves a kind of independently. So, and I can say end character in the end have to move end characters until the end. And start character in the first case have to move until the last char. So there should be n steps. So n plus n is 2n. So yeah, there are n steps, all of n steps in total for end index and start index. Good. Yep. So this is a space time complexity. And for space complexity, so this should be not constant, but linear. So I will think of the case when every character in the string S is unique, like this. In this case, when I move the end character until the end, that index never moves. Yeah. And, oh, sorry, I recorded left and right. And what happens is that all the A, B, C, D, E, F, G are included in the char count hash map, char counter. Yep. And each value should be 1. Yep. Number of keys is n. So in this way, the extra space complexity should be O of n for the char counter. Yep. In the worst case. Okay. Now I will start the implementation. So here, I move the end char and I shrink the, start char as less as possible. Because, as I said, I'd like to make each window as long as possible. Oh, sorry. And here, as I said, I have to check if moving the end char causes the increase of the numdup chars. So if this is true, numdup chars should be incremented. Okay. In this case, I move the start char. Yeah, like this. But before moving this char, I have to decrement the char count. Yep. And as I said in, where is it? Line 33, if decrementing causes a single character, it means a new number duplicated char should be decremented. Yep. If moving the start index causes that char count becomes 1, num duplicate char should be decremented by 1. Good. Okay, so I've implemented line 38. Now what I should do is update the return global max ranks. So this is local maximum length whose end index is current end index. So the ranks should be n minus start plus 1. Then global max ranks should be updated. Then this should be returned in the end. Okay. So I've finished the implementation. Let me quickly read my code verbally. So I can increment the counter of the chars and non-duplicated chars and global max ranks, which eventually returned. And I move the end index, and for each end index, I, find out the maximum ranks of the substring with the duplicate chars, which ends with the end index. Yeah. Current end. Yeah. Which is signified as the local maximum ranks. And I will update global max ranks every time, and I return it in the end. And for the logic inside of the loop, firstly, after moving the end char, I increment the char count of the end char. And moving the end index causes the duplicate chars. Yeah, num-duplicate chars should be increased by 1. And after that, I will shrink the window as little as possible by moving the start index. Yeah. So as long as there is a duplicate chars, I increment the start index. Yeah. And when I move the start index, one char is popped out from the window. So I decrement the char count of the start char, and then also decrement the num-dup chars if moving start char causes decrease of the duplicate chars. Good. Okay. So let me quickly walk through my code with a simple example. Like this. Yeah. ABA. So in this case, the longest string to be returned should be 2. So firstly, char count should be an empty because there's no character, and num-dup chars should be 0 and global max rank should be 0. And n, this one is now 3. And start index is now 0. Yep. Okay. And I move the end index. And firstly, when end index is index 0 in line 65, char count Sn incremented, so A becomes 1. And in line 66, because Sn, which is A, and the char count of A is only 1, which is not 2, so num-dup chars is not incremented. And in line 69, currently num-dup chars is equal to 0, so I don't go into the while loop and go to line 74. And the local maximum ranks is now 1 minus 0 plus 1 is 1. So global max ranks becomes now 1. Yep. So for this is as expected. And when I move the end chart 2, index 1 in line 64. Now in line 65, Sn, which is B, should be incremented. So this becomes like this. Then in line 66, yep, on count of B is not 2, so no num-dup chars update. And in line 69, because num-dup chars is still 0, I go to line 74, and local max ranks is now 1 minus 0 plus 1 is 2, so global max ranks becomes 2. Yep. And that's it. Finally, when end index is at index 2, yeah, this has something interesting. Okay, so char count Sn is incremented. So A is now 2 count. And then line 66 becomes char count A becomes 2. So num2 chars should be incremented by 1. Yeah. And then line 69, now num2 chars is more than 0. So I go to line 70. And char count S start, which is A, is decremented by 1. Now it becomes 1. And num2 chars is decremented now because char count of A, which is 1, is equal to 1. Yes. So this becomes a 0. So, and start is incremented by 1. And now I go back to line 69, and num2 chars is equal to 0. I don't have to shrink anymore. So I go to line 74, and local maximum ranks is 2 minus 1 plus 1 is 2. And global max rank is 0, 2. Yeah. So, and eventually this is returned. Okay, as expected. Good. So this passed. Nice. Okay, so I covered all the lines in my implementation, and also every behavior in my dry run was exactly what I expected. So I'm pretty sure my code works. I will submit. Good. Okay, accepted. Okay, so now I finished my... Oh, let me quickly wrap up my today's coding practice. So today's in my today's question, I was given a string S, and I found the ranks of the longest substring without duplicate chars. So the first approach, the brute force approach was that for each start index, I find the end index, which makes the longest substring without duplicate chars, and I do it for each start index, and finally I return the maximum length of each substring I created. Yeah. But I could optimize this with sliding window approach. So basically, I move the end char and the index, and I try to, I move as start char, sorry. For every end index, I move the start index as little as possible. As little as possible means that I move the start index if there's still the duplicate in the window. Yeah. But if there's no duplicate, I don't move the start index anymore. So in this way, I use the 2 pointers. And the time complexity was O of n. Yep. So in this way, I could find the longest substring lengths for each end index, and I return the maximum one. Okay, that being said, I finished my today's coding practice. Thank you so much. Bye.